Hello, welcome back to another nice exponential equation, and we're going to solve it. It's so amazing, it's so beautiful, it has a pretty idea. So stay with me. Please like the video. If you didn't like it, please tell me in the comments what you didn't like about it, and this makes the channel uh, to provide with better content. And so let's get right into it. And these type of questions, I always advise that at least my personal way is to just attack it by substitution, but because substitution would reduce the amount of variables in exponents. What do I mean? And also you should pay attention to the numbers here because we're just dealing with one variable and one number. So in substitution, one wise way of substitution in here is to put x as 2021 to the power of t. Why? Because if x is 2021, the base here, we could just omit one x and work with the two x's. And what do I mean? Let me just go ahead and show you. If you just do this substitution, we would then, our equation would be 2 to the power of 2021 to the power of t times 2021 to the power of t times 2021 to the power of t times 2021. This equals to 2021. And so here is our equation, but in a different form. So here, as you can see, we just got rid of one of our exponents, which was pretty bothering. So we know that exponent of this number is 1. And so our new equation would be to equal the exponents. So we would have t times 2021 to the power of t times 2021 to the power of t times 2021 equals to 1. So here, let's just divide both sides by t. So we have 2021 to the power of t times 2021 to the power of t times 2021 should be 1 over t, which is t to the power of -1. And again, you see here we just have two variables here. Let me just do a substitution again here. And what I want to substitute is again, just like the previous one, is t equals 2021 because we have the base of 2021 on the left hand side. I will put 2021 to the power of, let's say, a. So our final equation would be here 2021 to the power of 2021 to the power of a times 2021 to the power of 2021 to the power of a times 2021. And that is our final problem. This equals to 2021 to the power of -a. And so here, if you just simplify this a bit, this would be 2021 to the power of a plus 1, and this times here would be, let me write it again here. The whole equation would be 2021 to the power of 2021 to the power of 2021 to the power of a plus 1 plus an a is equal to 2021 to the power of -a. So that is our final equation, which we are going to solve. And I promise you, I'm not gonna use again the substitution. So here is our final equation, but and again, because we have the same basis, we just compare the exponents. 2021 to the power of 2021 to the power of a plus 1 plus a should be equal to -a. And here, please pay attention. We have um, here we have if you just look, you can easily say that one trivial answer is a equals -1. If you just put this, it is -1 plus 1, which is 0. 2021 to the power of 0 is 1, plus -1 is 0. This is the left-hand side is 1, and also -1 is 1, and so it's equivalent. But to show that it is the only answer, let's just take a, -a, to the from right hand side to the left hand side. We get to 2021, the power of a plus 1 plus a equals 0. Let's say this function is f of x. So if I just prove that f of x is strictly increasing or decreasing, I just prove that this is the only answer. So to do so, I don't have any way other than taking the derivative. So if you take the derivative, we would get the derivative of this thing would be 2021 to the power of 2021 to the power of a plus 1 plus a times ln of 2021 plus 1, the derivative of a is 1, should be now in here we just have to specify whether this is increasing or decreasing. And how do we know that? By just knowing the sign of this whole thing. So we know that this thing, this whole thing here, whether a is negative, positive, fraction, or anything, this is always positive. And we know that ln of something is always positive, and ln of an integer, it is not a fraction. Ln of a complete number is always positive, and so we have 1, which is positive again, so this is strictly greater than 0. It is always positive, and so our derivative, when the derivative is always positive, what this means is continuously increasing, and so the function will look like something like this. I mean that this is always increasing. So if it's always increasing, we just have one root here. So yeah, that was it. You may have some easier ways. Please, I'll appreciate that if you tell me in the comments how you could solve this easier. If you have any ideas, please tell me. Please like the video. If you didn't like it, please tell me in the comments. And yeah, thanks for watching. Until next time, bye.